So I mentioned in one of the previous videos that one of the things we use scatter plots for is to make predictions about what's going to happen in the future of a data set or make inferences about what has happened previously in a data set. So to help make predictions based on data that's been gathered, we find a line of best fit. This is also sometimes referred to as a line of regression or regression line or trend line. The method I'm going to show you in this video is called eyeballing. Again, there's lots of other methods, but they require calculus. They require calculus 2, calculus 3. They require things that you're not ready for. We also can do it with a calculator, and we'll show you how to do that. But most of the time, you really can just do it by kind of looking at it and eyeballing it. Basically, what you're trying to do is draw a line that divides the plotted values in half. You want to get the same number of dots above the line as below the line and get it as close to the shape of those dots as possible. Once you find the line, you will want to have a slope and a y-intercept so that you can write the equation of the line, because we're going to be writing equations of regression lines, and they're going to be in your nice y equals mx plus b, with this being your slope and this being your y-intercept. Okay, so let's do an example. The first thing we're going to need to do is to plot these ordered pairs. We're going to look at the time Jake spends on homework and the amount of sleep he gets each night. So we're going to let this be our x and this be our y. We have to figure out how we can set this up. We've got sleep hours here. We've got homework hours here. Homework starts, the lowest is at 0.5, the highest is at 5. So we could say 1, 2, 3, 4, 5, with these being the half marks, so 0.5, 1.5, and so on. And then we can do sleep hours. The lowest sleep hour is 6, the highest is 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so now I'm going to plot these points. Again, I'm going over 0.5, I'm going up 8. I'm going over 0.5, I'm going up 9. I'm going to pause real quick and get these all plotted, and I'll be right back so you can see. You should do the same. Pause and plot all your points. Okay, so I plotted my data. Hopefully yours looks a little bit the same. One thing I want to point out, these two data points here that are the same, 3 and 7, there's nothing you can do other than just to have two dots in the same spot. So that's not going to change your plotting at all. So don't be worried when you see that. All right, now it wants us to draw a line of best fit. When I draw a line of best fit, I want a line that cuts these such that I have approximately the same number of dots above as below. If you can have some of your dots being intersected by this line, that's good, but it's not required. So this has got, 1, 2, 3, 4 dots above, 1, 2, 3, 4-ish dots below. So I'm going to say that's good. Okay, and then I've got a few that are right on the line. So that's pretty close to being right at all of these points. Yours may look a little bit different, and that's okay. Now, it wants us to write an equation for the line of best fit. So we've got y equals mx plus b. I need slope and I need y-intercept. To find the y-intercept, I'm going to come over here and I'm going to look at where does it cross the y-axis. I'm saying about 9. Again, this is an estimate. We are eyeballing it. Now I've got to find my slope. To find the slope, find two nice pretty points that seem to intersect. I'm going to say here and here, and say it looks like it's going down 1 and over. Remember your scale. On this we counted by 1/2, so it's going over 1/2, 1, 1.5. So 1.5 is how much we went over. So remember that slope is rise over run. So the rise was -1. The run was 1.5. So we don't want to put a slope in our formula that looks like that. So what you can do is grab your calculator and put -1 divided by 1.5, and it gave me 0.66666 repeating, which is -2/3. Okay, so use that little arrow button to convert it, and we get negative 2/3 is my slope. Now, I can use that to, oh, also, I should say, you can also use your slope formula, y2 minus y1 over x2 minus x1, and once you've picked two ordered pairs, use that in the slope formula. That would have gotten you that negative 2/3 as well. Now, I can use this formula that we've written here to make predictions about how much sleep Jake's going to get on a given night. So remember, our formula is negative 2/3 x plus 9. I'm going to go to example 2, and it says use the line of best fit we just found to estimate how much sleep Jake would get if he had 7 hours of homework. Now, remember, this is an estimate because we estimated the line of best fit. We estimated where we were going to find points in order to get a slope, so it's going to be rough. And when you're doing these on your own, your answer may be slightly off from the answer we put in the key. And don't worry about that as long as it's reasonable. Okay? So, Jake's homework time is 7 hours. Remember, X represented homework. So we're going to plug in negative 2/3 times 7 plus 9. And I'm going to work through that. You can use your calculator, or you know, if you want to be fancy, do it by hand. Negative 2/3 times 7 is negative 14/3, and then plus 9 is 13/3, which that doesn't really mean anything to Jake. So we're going to estimate that to be approximately 4.3 hours of sleep. Poor Jake. That is not a healthy balance between homework and sleep. We should be nicer to him. While using a line of best fit can give us a prediction for data outside the original data set, it's important to remember it's an estimate, like I said before. Remember, it's a line of best fit. It's not perfect. Over the history of mathematics, we have lots of different ways of figuring out the line of best fit, and the reason we have so many different ways is because nobody can agree on the perfect way to have the perfect line. So it's not going to be perfect. It's going to be an estimate. Even when the calculator does it, it's going to be an estimate. All right. You guys go ahead and try. I would suggest on your X's here, counting by ones, 0, 1, 2, 3, 4, 5. Here, I would count by tens, 10, 20, 30, 40, 50, 60, 70, 80. Yeah, count by tens and just estimate. And I'll see you for video 4. Bye.